Welcome back to the Circuit Revival, where today we're going to be having a look at this Audio M-Track Solo. So this is just a cheap audio interface. It's not the best build ever. It's a bit kind of wobbly and stuff, but it's come in because neither of the channels work. Now this does get power. We can just plug the USB-A cable into the back here and you'll see it lights up, but we have light shining on both the signal and clip LEDs there for input 1 and 2, which usually shows only if you're clipping the signal itself. It would normally be sort of blank if there's nothing there, green if it's got a signal, and then red if it's clipping. So I've listened to this and it just sounds like ground hum. So there's obviously an issue between the two, and it doesn't matter what you do, whether you change the input, whether you change phantom power on or off, or change the output or the gain, it all stays the same. So possibly a grounding issue or something like this. So we're going to start just by getting it open and try and see if we can see anything immediately. I'd probably say I don't really know anything about the insides of audio interfaces. I've got a fair few knocking around, and I figured I'd pick this one up, see if we can get it fixed, because then I can look to improve the microphone that I've got in the setup here. So I'm not quite sure how we're going to get into this, but there's just a bunch of screws on this. So I believe we'll start with just the ones on the back. I imagine these ones on the front are just for the XLR, and then hopefully this will allow us in. So we'll just get these undone. Okay, that's the ones on the back. See whether it looks like it's going to move or whether maybe there's some under the feet here. I think I can see maybe a little gap, so maybe there's some screws just under each of the feet. Yeah, there we go. So we'll just get the feet off of this and hopefully that'll allow us in. Okay, so we've just got 4 more screws on the bottom there. We'll see if we can reach into it with this. Just. You can see there, it's just the right size to fit in. Let's see whether this will just lift off now. Maybe these pots need to come off. So we'll just lift the pots off and see whether we can lift the lid up. First one came off really easily, but these ones are just a bit stiff. There we go. Lift up now. Okay, I'm not quite sure how to get into this. I can't tell if there's clips on it. I don't think I can feel anything underneath these stickers in the middle. Okay, it looks like there's some clips on this. We'll see if we can just get those undone. Okay, so my camera just crashed a bit there, but basically there's 3 clips, one here, and one here. And this lid just sits on top, so you just need to pry into the sides of each of them just to ping them up, and then the top flips off like so. So then we can see inside. So we'll start just by taking a look, see if there's anything that kind of stands out to us. We'll just come in a little bit. Okay, so there's nothing that sort of immediately stands out there, so we'll try and see if we can get it out the rest of the case here. So just a few more screws. Blue. I was kind of hoping to see something like maybe a blown capacitor or something that was sort of grounding out the board. And that's what was causing it, because the sound that's coming through just sounds like a bit like ground hum. And, okay, so we've got one little screw just off the side next to the XLR here that has a bit of like a rubber bush on it. Let's see if there's another screw underneath this serial code. Nope. So let's see, will this just lift up now? So we'll have to just take the XLR out as well. One more screw here. And we're out. So I'll start just by taking a look around the board, see if I can see anything now that it's out and a bit easier to see. Okay, so I've just had a quick look around there, and I'll be honest, I can't say I can see anything that particularly stands out as wrong with this. The fact it's showing up immediately on both channels makes me think that something is either sort of like not grounded or shorted out. So we'll start just by going across some of the capacitors and stuff and see whether there's anything on those, see if any of them are shorted. So I'll just stick my multimeter here into continuity mode, which is the mode that beeps when we have a complete circuit. And I'm just going to go around and just test the capacitors. So I'm just going to go either side of them and see if we get a beep here. So that beep there is not too bad, that's just the capacitor charging up. We'll just start with the through-hole capacitors first, and we'll work our way up to the surface mount ones afterwards. And what I'm listening out for here is just a beep. Okay, so I've gone through most of the through-hole ones there, and I wouldn't say I can find anything. So we'll just try the surface mount ones. Okay, so I think I've got something here next to one of these chips here. So it's just one of the capacitors. Now I think the noise gate on my mic might block out the beeping, so I might just turn it off for a second. But let's just get this capacitor under here. We'll just flick to the microscope view. So here we are under the microscope. You might find that the audio is a little bit noisy at the moment, just because I've turned the noise gate off of my mic, but we can see just next to this chip here, there's a few capacitors. If I put my black lead on ground and go against the top, I get a beep, and that's showing 1.2 ohms. If I go to the bottom of the capacitor here, I also get a beep, and that's also showing about 1.2 ohms. So I think that is a direct short to ground. Okay, because we are getting power into it, what I'm wondering is if we try go to the thermal camera, whether we might be able to speed up the process a little bit and see whether anything is getting hot. So I'll plug the thermal camera in here. We'll just move over to it. There we go, there's the thermal cam. So here we can see the board. What I will do then is I will try plugging this in and see whether we get anything. So I'm just going to plug this in now. We have our LEDs, and let's just come over the top of the board and see whether we have anything. So we have heat spot just over here. Just over here. That's a chip. We come around, there's a really big heat spot. Where is that? Just behind here. There's two capacitors down there and another chip, so that could just be the chip getting warm. A big one on here, which makes sense. This is, I'm guessing, the main brains of the board. These are just all reflections. Let's try get the macro lens on. This should hopefully allow us to see a bit clearer. So we've got both that chip and the capacitor above it getting warm. Then over here, just that chip. Work our way around. There's the main chip, I'd say, which I presume is sort of the brains of it all. I think it's just those two locations then. The thing that stands out to me here is the fact that the capacitor here is getting really warm as well. So the fact that they're both getting warm makes me think that that's where most of this power is running through. So we'll get this under the microscope and we'll have a look at this a bit closer. Okay, so here we are back under the microscope, and you can see this is the area that was getting warm there. And it's this capacitor here that I was saying that was getting warm. Now, I would say that doesn't look particularly healthy down there. It does look a little bit burnt in the area, like it has seen a bit of heat. The problem is we won't know whether it's the capacitor or the actual chip itself that's the problem. And the issue we've got is this area is so highly populated with capacitors. So you can see there's this big one here, this big one here, and then this other one here that I think this is going to be quite hard to get out. But what I think we might do is if we just unplug this for a second from the computer, and I'm just going to flood this area a bit with IPA. So I'm just going to put some IPA on the board down here. And I'm just going to plug it in and see whether that capacitor gets warm. Okay, so it looks like it's coming off of the chip first of all, and then the capacitor follows afterwards. So if I was to hazard a guess, our issue would be this chip right here, which is SL6LA. So what I'm going to do is I'm just going to pop onto the internet and see whether I can see anything about that. Okay, so I've had a look around the internet and I can't find anything about that part. Now what I was going to do is I actually bought another one of these to fix as well. So in the thoughts that if I couldn't fix one, I would fix the other, because online they both showed up as different faults. However, I've just plugged this one in and it's doing the same thing with the lights. So I imagine it's probably exactly the same issue with this. But what I'll do is I will just get the lid off of this one and plug it in, and then we can get it under the microscope, see if exactly the same thing is getting hot. If it is, then we know it is the same issue. And I will try and see if I can find some information about the part, but from what I've looked already, I don't think I can. So I'll just jump ahead to this one is open and we'll see whether it's exactly the same problem. So here we are back in the other one. So I've got this one here and here is the original. So what we'll do is we'll pull the microscope back around and we'll have a look at that same area and see if it's exactly the same spot that's getting warm. If so, we can probably presume it's the case, but we might try take some bits off and see if we can 100% prove that that is the fault on this. So I'll just pull the microscope round. Okay, so here we are under the microscope again. This one has a slightly different number on the silk screen, so we might try that and see if that gives us any better ideas. It also looks like it's kind of covered in, is that flux or just junk? Could be factory flux there. But we'll plug this one in and we'll chuck some isopropyl alcohol over the top of it again and see if this does exactly the same thing. So just move this into a better position. So there we go, there's the chip. What we can do is flood this area in IPA again, and I'm just going to plug the cable in now. And yeah, you can see that immediately gets hot. So it's either that chip or something it connects to. So if we try that again, it looks like it starts on that middle leg just here. If I just show you. So it looks like it originates just on this middle leg here in that area there. So we might just follow that trace back and see where that goes to, just in case it's something else that's causing the issue. And this is actually just the end result rather than the actual cause. So we'll try that again. So You can see it sort of fizzing in that front area as well. So if I just unplug this again, let's see if we can follow this round. So it comes up and it either goes into or underneath that capacitor and then into these inductors here and then around. So I'll pull the other board back in because this one's going to be a bit easier to troubleshoot because it's actually out of the housing. If we look, here's that chip again, and we can see that comes around underneath this capacitor. So I'll have a look just at the bottom here. It's quite hard to see because I think it's multiple layers of board, so it's going to be difficult to know. So I might just need to pull the meter out and trace this round. It looks like it splits around that track. So it looks like this comes off this leg here, up, goes up underneath this capacitor or to this capacitor, but also comes round to here somewhere. Maybe back into the chip on this top leg here. What we'll just do then is this, these two legs here that you can see, this is the legs of the capacitor there. Now what I'm going to do is just double check whether that capacitor itself is shorted as well. Like I say, you might not hear the beep through the microscope just because of the noise gate, but I'll just quickly test this and I can let you know whether it is. Okay, so that's not, that capacitor just charges up, but it's not a constant short, which makes me think then that it's not after this chip, it's either the chip itself or something before it. So we'll just see if we can follow this round a bit, because I know that if I come in here and here, so that's a direct short. If I come through the capacitor, it's also a direct short. That comes through into this inductor, that's a direct short. If I follow it through that inductor, that's a direct short. And then that looks like it goes to, gets a bit messy underneath here, I suppose. Maybe into one of these capacitors here. So we'll just flip this over again and we'll just test these capacitors. I think it's all these ones in this area here. And then these are the bigger ones. So we tested these at the beginning and these are not shorted. So everything is sort of pointing towards that chip being the issue. And given that both these have the same sort of symptoms and it looks exact same, I would imagine that that is the problem. But what we'll try then is, now that we have a different silk screen number there, I'll just try to see if that other number gives me any results online. So I've done a bit of digging around on the part number off of the board here, and that has come up as an SGM3204, which is a charge pump voltage inverter, which says that the applications could be an LCD panel bias, bipolar amplifier supplies, and GAAS bias for RF power amplifier. Given that this is a audio interface, it could be under the amplifier supply there. So it looks like it could be a thing, but I've double checked the two boards here. They both have the same areas getting really warm, but there's a difference in the short. So the first board on the capacitor in that area, there was a short on it, but on this board the same short doesn't exist. So I'm now wondering whether it's not actually that's the issue. So on this one there's a tiny little capacitor just here that's shorted, but on this one that exact same capacitor, which is just here, is not shorted. So I'm wondering whether maybe it's something else that's causing the issue onto that chip. So I can continue sort of tinker around on the board here. If I find anything, I'll jump back in. Okay, so I'm gonna try and see if we can prove the fault basically. So I've got the camera set up under the microscope here. If we just move over to the microscope, we can see I've got the board sort of semi hanging off the board because there is so many capacitors in this area and so much plastic. I'm gonna try and see if I can heat it up from underneath and get these items off. So the capacitor that's shorted on this board is this one here. Now I'm still fairly certain it's the chip because that's what's getting hot first, but I'm thinking maybe I might try one by one and just move these components off and see if we get anything different. Now I don't know how important this chip is here for the actual use of it, but I'm trying to work out whether maybe we can try and get rid of the issue, and then we can look to replace it afterwards. Now I'm hoping it's just going to be the capacitor because that's the easiest thing to replace, because the SGM chip that I found actually has a schematic that tells you sort of what capacitor and resistor values go next to it. So if it is that, we'll see if we can replace the chip, but we'll start off just by trying to pull bits off and see if we can at least sort of prove what the fault is. So I'm just going to do this my hot air station, and as I say, I'm just going to try and heat it up from underneath. That way should hopefully not cause any issues with the capacitors themselves or any of the plastic, but should hopefully heat it up enough for me to at least just lift the parts off. So I'm going to turn the hot air iron on now. I will add just a tiny bit of flux just to try and help this along, and then we'll heat it up from underneath and see if we can just lift the bits off. So we'll just get a bit of flux in here. We'll start just by trying to move that capacitor over a bit. Okay, so it's not really getting anywhere, so what I'm going to try and do is just add some leaded solder to the area. Now, it's really small and my iron is not quite small enough for this, so it's going to be a bit tight, but I'm hoping I can just get a little bit of leaded solder in there and try and reduce the melting point a bit. Okay, there we go. There's a bit of leaded solder on there now, so I'll bring this back over the edge of the board and see if we can do this. It might just be that the board is sort of too thick and the area's not really good enough for this, but we'll give it another go. Okay, that worked quite well there. So I've just moved the capacitor over. So what that should do is remove it from the actual kind of path there. So we can then see whether it's doing anything different. Now that could be the input into this chip, so it might just do absolutely nothing. But we'll also be able to test the capacitor itself there to see whether that's the issue or whether it's the chip itself. So I'll grab my meter again. So you possibly won't be able to hear this, but I will let you know. So I'll go into continuity mode again, and we'll come in and we'll just go either end of this capacitor. Okay, that capacitor is beeping. So what we might need to do then is just let this cool down a bit and see whether it's still shorting and whether that chip is still getting really hot. Because on this board it could be that that capacitor is the issue, which would be nice if it is, given that that chip's hard to find. So what we can do is just clean this up a bit more. Oh no, okay, so I think I accidentally had my probe touching. No, it might have just been where it's still hot. So if I go on to the pad for that chip there, because this bottom pin here, I'm in a bit. So we're just looking at this area here. So this pin here is ground. This top pin is where I've just moved that capacitor over from. So we see that that one is beeping. and then if we come up to the top pad, that is clear, that's still beeping. So I think that proves it is that chip there then. So now this is cooled down a touch more, what we can do is plug this back in and have a look again at what the thermal cam is showing. So those lights are still on. If we move over to the thermal cam, you can see that chip is still getting very warm. So we can try remove it and see what it does. The chances are all this will just then completely stop working though, because I'm guessing that is obviously important for something. But we can try do that. So I'll just add a bit of leaded to that chip as well. And then when we lift it off, we'll try and move that capacitor back into place as well. Yep, so here we are back under the microscope here. And what I'll try and do is just add a bit of leaded to this chip, because it certainly helped last time with lifting it off. Okay, that's got a bit of leaded on it now. So we'll just lift this board back up again. I think I might just need to add a little bit of solder to that pad as well for that capacitor, just to make sure it comes back in right. There we go. So I'll do exactly the same as I did last time. I'll come in and this time I will lift this chip off the board. Okay, I'll be honest there, I think that actually went pretty smoothly. So the chip came off nice and easily. I don't think we caused any damage to anything. Probably about as well as that could have gone. That lead had made a massive difference. Okay, so what I can do is get my meter back out. We'll go into continuity. Now the board's still going to be a bit warm, so it might be a little kind of skewed, but we should see on this pin here low resistance, because that is ground now. Hopefully we come to this top pin, that's now gone. So that top pin there that I'm on right here was originally shorted, which would make sense that this chip here, and I've gone diagonally just there across the two pins on the chip itself, and you saw it red. So that chip is definitely the one that's at fault. So we'll just see if this is cooled down a touch. It looks like we are there. We'll see whether it does exactly the same thing. Now it might not do anything at all, because that chip might actually be really important, but as that sort of cooled down a touch, we'll try plug this in and see if it does anything different. No. Okay, so those lights are still both on. That's interesting. And changing the dials does nothing. Okay, I was fairly certain that was going to be the problem. Well, what we can do then is move back to the thermal cam and see whether we've got anything different now. Now it looks like there's more areas of the board hot, but that's probably just residual from the heat we put into the board there. Okay, so whilst I was waiting for this to cool down, which we can see it has done now, I decided to do what a lot of you probably would have done from the beginning and actually Google the issue and see whether it's a common issue. And from what I can see, it very much does seem like it is a common problem with these devices. And everything I've read has pointed towards that chip that we just pulled off. So I'm glad that we did this, because it's quite nice to know that I'm actually fault find it myself. I know we use some kind of fairly advanced tools with the thermal camera and stuff, but it's nice to have been able to actually kind of find the issue without just Googling it and then copying it. But what we'll do either way is it's cooled down now, so I'm going to plug it in again and just see whether anything else does happen. I'm still a bit confused as to why those lights are coming on, but I'm wondering whether the LEDs still come on regardless because it can't see the other signal there. So if we put there's the main chip that was getting warm there. There's the other one that we had that was getting warm. And everything else, as we can see. Although there's some other things getting warm here now, which I don't think were before, which is kind of positive. But I am still confused by those lights still being on there, because I would have thought that they would have gone out now that we've got rid of the issue. But the fact that we've got other things on the board getting hot now is helps prove that that was the fault, because we've not got we've got power to parts that we didn't have before. So I think what I'm going to have to do is pause this for now and order in some replacements for those chips there. So they were the SGM 3204s. Hopefully if we get those on, then I'm hoping that these LEDs will turn off and it will just work, because I'm surprised they're on anyway, but we'll just have to wait. Okay, so it's been about a week now, and the replacement chips have turned up. So we'll get this installed and see whether it works. So I'll just start with the one that we've already removed the chip from, because it's just a bit easier to get out the case here. So if you remember, it's just around here that we're looking. So we'll pull out these board holders again, hold this board in place, because what we'll do is we'll do the same again, and we'll heat it up from underneath. And then we'll just drop the chip on and hope it should melt, because it's still got leaded solder on it. So we'll just bring the microscope round. Okay, so you can just see here where the pads are for it. So I might just try and add a little bit more solder back to these just to help them, because this side looks okay, but this side looks like it's still lacking a little bit. So I'll try and see if I can get my soldering iron in there just to get a little bit on. But we'll just start with a bit of flux. Okay, that looks good. Just give it just a tiny clean up just to double check. Probably a bit too much on that end pad there, but I don't think we're going to be able to get much better than that. So I'm just going to move this off to the edge of the table a bit more, just to help me be able to get the iron and the wand underneath there. So what we can do is just get our replacement chip. I'm just going to add a tiny bit more flux this, but before I do that, you should hopefully be able to see just in the top right here, sort of slightly hidden under this flux there, there's a little white dot that signifies where pin 1 is. So we just need to orientate the pins so that they're there, and on the chip itself it also has got a corresponding dot. There we go, there's the replacement chip. So these worked out to be, I think it was about £2 for 10 of them. So not bad at all if you've got the tools and the ability to kind of do this. So we'll just spin this around, try and get this in place. Nearly there. Okay, that looks good there. So you can see there's the pin in the top corner there. So I'm going to do exactly the same again. I'm going to heat it up from underneath, and then hopefully as that starts to melt, that chip should fall into place. Okay, so hopefully you could see there the chip starts to sort of like dance into place a bit. So whilst this is still a bit warm, we're just going to come in and try and clean this up a bit, because I think that looks nice and attached. We'll double check the joints either way, but we'll just add some IPA to this. Let's just see if we can tilt this around and have a look at those solder joints a bit clearer. So that one in the middle looks like it might not have enough solder on it. That side looks pretty good. And it may be connected there. Okay, so we're just gonna leave this to cool down a bit because you can see all the hot glue there still all melted from the LED stand. So I'm just gonna let that solidify, and then we'll try plug this back in again. Okay, so that glue is started to solidify a bit here. So we've got it together, and I have the lead plugged in again. So what we're hoping for is when I plug this in, us to not see two red LEDs. I'm hoping neither the LEDs should turn on. So let's give this a go in 3, 2, 1. Okay, so do you see they went green and came off? If we twist this. Okay, so that's positive, and when we turn this we can see it looks like it's obviously showing up because the gain's turned up, so this so far looks pretty good. So I'll just disconnect this. What we'll do quickly is we'll get the other one installed. We'll put them both back together. I'll grab an XLR mic from downstairs and we'll test this out. Okay, so just to remind you what the error looked like before, so this is the other one before I've taken it apart. If we plug this in, you see both LEDs are showing as red there. So we'll get this one taken out and I'll swap the component on this one and see whether we have two working units. Okay, so we've got this unit out as well. If you remember, the actual symptoms of this one were slightly different, even though the error is the same. So we'll see whether this does fix both of them. But what we'll do is we'll get this back in the clamps, and then I just need to get some leaded solder on this, and then we'll do exactly the same again. We'll heat up from underneath, pull the old one off, and then drop the new one on. So we'll just bring the microscope back around again to make this a bit easier. And then if you remember, this is the one that actually allowed us to find what the component was because it had a slightly different number on it. Whereas the component number on the other one didn't show anything. So I'm just going to get some leaded solder on my iron. I'm going to carefully come in this gap. Okay, so it's still bridged together slightly, but that's not an issue because if you remember, we're going to just lift this off anyway. I'm going to come in with my left hand. It's not my strongest hand here. Just get a bit more solder on my iron. There we go, so that has added some leaded solder to it, so it should be a bit easier. So we'll do exactly the same with this to get it off, and then we'll just swap it straight out for the new one. So I'm just going to get the new one prepped and ready. Okay, so I've got one just on my desk here, so we'll start heating this up. Okay, so only one side, the side with all the solder on it, was starting to lift. So what I'm going to try and do is come in and just add a bit more leaded solder to the other side because it just doesn't seem to want to lift up as easily, and I don't want to tear any of the pads off, so that should have a bit more. So hopefully that melts at the same temperature. Okay, that's the new chip in place, so we'll just do exactly the same again, heat that up from underneath, and then hopefully it'll flow into place. Okay, so that one didn't look like it quite bonded as well as the last one, so I'm just going to come back in with some solder on my iron and just try and see if we can just tap in place those top two pins there because they don't look particularly solid to me. Okay, try and see if we can get a different angle on that. See how that looks. Okay, so that glue side go white again, so it's gone hard. So we're going to do exactly the same again. We'll take our little cable, and hopefully we shouldn't see two red lights. Nice. Okay, that's good so far. So what we'll do then is we'll get these back together. I'll grab just an XLR mic from downstairs, and we'll give this a test. Okay, so there they are, both back together completely. They went together quite nicely, actually. Okay, so I've got here an XLR and then just an SM57. The studio was a bit of a mess, so grabbed the first two things I could find. So hopefully what I think we should be able to do is if we plug this in, I'm thinking I should be able to add it as a device. So if I plug this in, and then this end into the SM57, I'm hoping I should be able to turn the mic down that I'm using currently. So if I turn that down now, hopefully this should start to work. Okay, I can see the level there if we come back up. So what you've got here is just the SM57 coming through. So I'll have to double check against how that works, but you can see the signal level is coming up here. So we have that. And then the output is not going to do anything because it's not got anything connected to the output on it. It should just be coming through the USB. So that one looks all good. We'll plug the other one in and see if that works. Okay, so we're back to the other mic just so I can sort this all out. So we'll unplug the XLR, plug it into the other one, unplug the USB, put that one off to the side. And then if we plug this one in, cool, so we get the lights there again, and okay, so I'll turn the main mic down and swap to the other one again. Okay, so hopefully we should also have audio here. I can see the level in OBS, and we've also got the signal level. This one's a bit higher, so maybe it's just clipping there. And you can see as I talk, this is flashing. So looks like that's two wins there. We won't know fully until I jump over and just edit this. So what I'm going to do quickly is just jump in, watch the video I've just done, just to make sure this is recording in, and then we'll change the figures and then see whether this is a fix or not. Okay, so I've just gone back and double checked the footage there, and that is indeed working. So that is another fix there. So if we come to our scorecard, we can just change that to be 6-0. So I'm going to say 6, even though technically there was two devices there, but it's kind of mad to think that both of those have failed because of this tiny little thing here, and especially considering it looks like it's a common problem that's going on with these devices. So I don't know exactly what that item's supposed to do or why it doesn't do what it's supposed to do, but it's kind of mad to think that so many of these seem like they're breaking. So if you ever have one of these and it does have the two red lights there, that's the component you need. The I think it's the SGM3402, I think it was what it was. But either way, that's another fix. Thanks for watching, and we'll see you in the next one.